Math 13 students, hello. A little bit of detail on 8.1. There's a lot of stuff in here. I'm going to take a look at hypothesis test outcomes. There's some subtlety and detail in how we like to address and convey those results. So let me jump over to my other screen and we'll take care of that. Okay, so a little bit more on 8.1, hypothesis test outcomes. All right, so at the end of the day, there's really only two possible outcomes. They are mutually exclusive. They cannot happen at the same time. Either the null hypothesis is more likely, or the alternative hypothesis is more likely. Remember, we deal in probabilities. If that null hypothesis is more likely to be true, we really are just talking about the chance that it's more likely to be true. This is not proof in the unequivocal sense. If the alternative hypothesis is more likely to be true, we'll acknowledge that, but we'll also understand that there's a chance that we might be wrong. We'll talk about error at some particular point in time. Now, I will point out that if our evidence is strong, and really we do have a particular perspective here. We're very much like the prosecutor in a criminal court case. The desire, if we are a scientist, is to dismiss the null hypothesis and to go with the alternative. So if the evidence is strong, that would be the test statistic and subsequent p-value. If that's the case, if the evidence is strong, then we reject the null hypothesis. So let me really emphasize that. When evidence is strong, we dismiss the null hypothesis and will believe that the alternative is more likely to be correct. On the other hand, if the evidence is weak, in other words, the test statistic and the p-value really are not that strong, we fail to reject the null hypothesis. And it's really important to realize that we're not validating the null hypothesis. We're just saying there's not enough evidence to reject it. It's a completely different kettle of fish. And it's very similar to what happens in a court case. A court case comes back with a verdict of either guilty or not guilty. They never come back with a verdict of innocent. They only say if the evidence rose to a level high enough to come back with a level of guilty. And it's important to remember that once the test outcome is determined, there's more to the job. We need to address the initial claim. And this initial claim here is the claim. Sometimes it's the null hypothesis, sometimes it's the alternative hypothesis. It's the claim that we encounter when we first read the problem. It's what's written into the problem. We'll see an example in a moment or two. And this is important because we'll want to remember that at the end of the day, this test outcome, whatever it is or isn't, at the end of the day, it is and this is the important part, it is a numeric statistical process. It is the result of a bunch of number crunching, phrasing of problems, and the like. On the other hand, addressing the initial claim addressed what actually happens. How is it relevant? Was the initial claim true or likely to be true? So we'll need to address, as I say, that initial claim. So it's really a two-step process at the end. Once the calculator and the calculation tells us what we need to know, we really need to address the initial claim and convey those results. Now let's take a look at an example or two, and then we'll be done here. I wrote these out to see if that helps the process. So we have a claim that more than 62% of Hartnell students are registered owners of a motor vehicle, and that produces a particular p-value. So we have a claim, more than 62%, and we have a p-value. And we want to determine the outcome of the test if the level of significance, that's the chance of a mistaken null hypothesis, is equal to 0.05. So what I like to do is I like to translate this into the null and the alternative hypothesis. This is a population proportion. P is greater than 62%. So and it is the alternative hypothesis here that is the claim that we encounter. That's our initial claim. Now we have a p-value, and it's important to remember, because this is the way this section starts out. This is the p-value we develop here in 8.1. The p here is a lowercase p. It is a population proportion claim. So we want to compare this to the alpha. So, and then I'll need to remember the rule, and I can talk about the rule as we go along. So this is really where the important stuff happens. We want to make sure we get the direction of this inequality correct. So this inequality, let's see, 0.0329, that's the p-value. That is less than the alpha of 0.05. So when p is less than alpha, that tells us that we will reject H naught. So in this case, the outcome supports the alternative hypothesis, which is the initial claim. And again, p less than alpha is how we make this determination. P less than alpha means we reject the null hypothesis. So in this case, that outcome supports the initial claim because my initial claim is the alternative hypothesis, which we go to after we reject the null. We have another one. We have the claim that the mean wait time at McDonald's is less than 14 minutes, and that produces its own particular p-value, and we'll run through the same general process here again. So, less than 14 minutes, the mean wait time. So, in terms of notation, that translates to mu is less than 14 minutes. Here, my null hypothesis, and then the alternative. This particular claim is my initial claim. That's the one we encounter. Now, here again, I'm going to compare the p-value to my alpha. And I'll note I've got a p-value of 0.0612, and I'll compare that to 0.05. When I do this, I always place the p-value on the left and the alpha on the right. 6 pennies is bigger than 5 pennies every day of the week. And this is where I'll need to remember that when p is greater than alpha, and this is the one that sounds a little odd, we fail to reject the null hypothesis, which means we're going to keep that null hypothesis. Take a look at that wording. Fail to reject. And that's what we do when the p-value is greater than the alpha. Now, what does that mean? It means we're going to stick with the null hypothesis, but our claim was the alternative. So data here do not support. And then I always like to state the claim, mu less than 14 minutes, and the level of significance. And there's a couple of reasons why we do that, and I'll get into that later. So you've seen a couple of examples there. I hope that helps with the summarization of a test of hypothesis. I'll post this and we'll get on to the next. Thank you.